Okay, so what I want to do today is go over the requirements for your third and final programming assignment. And what we're going to be doing with this one is a little bit different from what you did with the first two. The first one, you implemented the hill climbing algorithm with random restarts to solve the n queens problem. The second programming assignment you guys did, which you wrapped up recently, was A*, where you implemented that algorithm to find a path between two nodes in a grid. And what we're going to be doing with this next programming assignment, you are going to be coding a game agent to play a game against other people's coded game agents. Okay? And so what we're going to do today, I'll show you how the game works. So we'll see that, and I'll kind of walk through what it is that you're going to be doing, and then we'll walk through some different strategies for how you can approach this problem. Okay, remember last class we looked at game AI, specifically looking at finite state machines, where we had a series of states, we had a group of actions for each state, we also had a set of transitions between the states. Okay? A finite state machine is one approach to coding your game agent. Okay? So let's get this pulled up. If you click on the third programming assignment, you will see that there's no conflict.
I think if you go through files,
we'll get it set up. All right, I'm going to add this to the assignment. All right. So, okay, so now you should be able to click on this and it's going to download a project. Now, this is going to download the source project for this game, and the game was created in Unity. Now, if you don't have any experience with Unity, that's totally okay, but you will need to download the software. So what you're going to do is you're going to go to unity3d.com, and you're going to need this in order to complete the project. Okay? Then you're just going to click Get Unity at the top, and then just grab the free personal one and click Download Now. Okay? It'll take a while to get everything going. Alright, I'm going to open up what it is that you're going to download, and we'll walk through the whole process. So you'll need to unzip it. And like I said, Unity's free. There are paid versions of it. There's no need for you guys to get that. The free version will give you everything that you need. So go ahead and we're going to download it. And once it's downloaded, we're going to go ahead and open it up. Right? Inside here, we're going to see a series of folders. I'm going to post this video for you guys to reference this later in case you need to figure out how to do this again. At the top, there's a folder called Assets. Click on that. And then you'll see what is called a scene file, a Unity scene file menu. That's what you're going to open. Okay? Now, when you open this, you're going to get a warning. Your project was last opened with a different setup of Unity. That's fine. Just click Continue. This is because this particular version of the game is a little bit old. It was made in an older version of Unity. It'll still work fine. We are in the process of updating it to add a few more features and adjust a few things. But it's definitely good for what we'll need to be doing here. All right, so first time it loads the project, it takes a little bit of time. All right, so once it finishes, it's going to open it up. And you can ignore any of these little warnings or comments that it gives you down at the bottom. Again, most of those are caused by some of the stuff being a little bit deprecated or outdated. It'll still work fine. Okay? So to start or to run your program or your game, simply click on the play button up at the top. Okay. Now you have a couple different options. You'll notice it's running in this small screen. So I'm going to click play again to stop it. And then you'll notice there's a scene tab and a game tab. If you flip over to the game tab and then right here click maximize on play, then when we play, it'll be full screen. Okay. I'm going to lower these lights a little bit so you can see better. So, the way this works is there's two players. There's red and there's blue. I think it's actually blue and red. And when you guys write your scripts, you're going to submit those, and I'm going to drop them into a folder, and you'll see those pop up here. Okay? They're going to pop up on both sides. So, I'll click on Bob, and I'll click on Joe, and I'll click Go, and they'll play each other. Okay, that's how it works. All right, so to show you a sample, we'll walk through how the game works, and then we'll get into specifically how you do what you need to do. So there's some sample AIs that come with it. I'm just going to click 2, and then click Go. Now I'm going to pause this as soon as this starts. Okay. So what we've got here is we've got two sides. We've got the blue side and we've got the red side. Now the way this works, where the game works, is pushing on a button. Is there a glare on this? Can you guys see this okay? You want me to lower these blinds? Yeah. See if this helps. Is that better?
Let them hear the amazing music.
They'll hear it enough, I'm sure, as they're testing it out. All right, so the way this works is, you notice there's a series of buttons on each side. Okay? There's also a series of mines or bombs in the middle. If you push a button on one side, it starts the conveyor belt and slowly moves the bomb to the other person's side. So the red guy hit the red button at the top, started going this way. Blue guy at the bottom hit the blue button, started going this way. Okay? As you go, you're going to hit buttons, and it's going to send the bombs. Now, if the blue guy gets all the way up to the top and he hits this button, it'll simply reverse it and send it back the other direction. Okay? You've got 8 lives. You lose a life every time a bomb explodes on your side. And a bomb explodes whenever it reaches the end. Okay? So we're just going to let this play. Switch over to the game view. And you can see how this plays out. Click restart match, just reset everything. Now, there are obviously some elements of strategy and things you need to take into consideration. For example, at this point in time, let's take the blue guy for example. He could either decide to drop down and hit this one, knowing that the red guy is below him, Or he could decide it makes more sense to go up and hit these. And the question is, well, if we're going to go up and hit these, is it better to go skip these two and go up and hit this one, and then this one and this one? Is he going to be able to get to this one in time? Or does it make more sense just to hit this one and this one, and then let this one go? Okay? So there's a ton of strategy, and there are a ton of things you need to take into consideration when you are coding these guys. Okay? And what we're going to provide to you, and we'll look at this in just a second, we're going to provide just a simple set of API calls that you can say, move up, move down, press a button, as well as a bunch of calls that you can make to get information about where the bombs are, where the other player is, what buttons have been pressed, the direction the belts are going, and all that sort of stuff. Okay? So you'll have all the information you need, and it will be up to you to filter through that information to figure out what it is that you want to use to make the best decisions about how to play the game. Okay? Questions so far? All right. Let's take a look at, so downloading the project will allow you to open it up and play it. Let's take a look at the framework. These are your instructions for what you're going to be doing. So, using the provided Bomber Belts Unity project, which we just looked at, write your own AI script for the character to play the game. Your script will be used on a character, while another classmate's script will be used on the opposing character. Information below on how to write the code. All right, so download it, not from Moodle. We updated it in 2015. Download it from Canvas, just like we saw. Again, this lists the instructions for what to do. Open the scene name menu inside of the assets folder, which we did. And then this is where we get into information about where the scripts are. All right, so locate the AI template.cs for C# file inside of assets, resources, AI scripts folder. So if you go back, this is what we downloaded. Remember, we opened up menu. We had the bomber belts. We clicked on assets. Click on resources, and then click on AI scripts. Here are all of the scripts that we saw that popped up in the game. Okay? And again, it tells you exactly how to get there using this. Okay? So notice, if I go here, we've got 1, 2, 3, 4, 5 scripts here. When we run it, those are the same 5 scripts that pop up here that we can select from. Okay? Alright, so locate the AI underscore template file, which is right here. Okay? Next thing. Refer to the information below on available functions to call. You can also use the sample ones that are there already as a basis for how to figure out some stuff. Okay? So let's go ahead and open it up and see what we get. So Unity comes with its own IDE called MonoDevelop. Should be a little easier to see.
I always prefer the Visual Studio one because it's better.
It's easier.
Yeah, just buttons.
Now, Unity comes with MonoDevelop, which is an IDE that you can use to code. That's what this is. If you have Visual Studio on your computer, you're welcome to use that too. There's lots of different IDEs that will work with this. Any C# editor will be fine. You'll notice there's already a bunch of code in here. You don't really need to know what this does. Okay? What I want you guys to do is scroll down to this function called update. There's already a comment here that tells you this is where you write your code. And you don't need to write any other code in any other class. This is all that you need to do. You write your code right here. Now, if you want to call, bless you, if you want to, bless you, set up separate functions inside of this class, you're welcome to do that. If you want to put everything inside of the update call, you're welcome to do that. Update is called once per frame. Okay? So whatever you write here is going to get called every game frame. And depending on the computer that we use to run these, it'll run 50, 60 frames per second. Okay, so whatever code you put inside here is going to get run several times a second. All right, that makes sense? All right, now, you can get as fancy and advanced as you want. You may not, or I should say you should not, make any modifications to any other scripts from here. Okay? Obviously, if you know what you're doing, even without going into any other class, from here, you could modify other stuff in the game. Okay? That would be considered cheating, and you would get a 0 if you do that. Might be a little bit funny, but don't do that. Okay? All right, so now that we know where you write your code, let's take a look at what it is you're supposed to do and how you write your code. So, make sure you change the name of your script to AI script underscore your name. Now, don't literally put this. It's always one. Okay? Let it be known, going on record, going on tape, don't put the words your name. Actually put whatever your name is. So, for example, if your name is Bob Jones, you put AI script underscore Bob Jones. Okay? We're good with that. I'm laughing, but I'm not. My name? Yes, it is points. And all of you, this is a 3,000 level programming course. All of you at this point in time should know this. In case you don't, because you're changing the name of your file, your class name has to change as well. Okay? We're going to run these, and we're going to do like a little competition in class. If you have errors in your code, whether they're exceptions or compile time errors, we will see them. Everyone will see them. Don't be the person that has the wrong class name because they changed their file name and didn't change the class name. All right? Question? I'm kidding. We'll fix your errors. Maybe make a little bit fun of you, but we'll fix your errors. All right. So it says don't make any changes to other scripts. Like if a bomb gets too close to you, teleporting the bomb to the other side would be cheating. Don't do that. Again, it would be funny, but don't do it. All right. So here are the available functions that you can call. So read this right here. This is important. It says all of the functionality for moving your character, sending bombs, positional state information of the belts, and the bombs have been written for you inside other scripts. Okay, so we've already written the code for you to access that information. And the way you do it, you can access those functions by using the main script variable that is already declared and initialized for you inside of the template file. Okay? So, this below is a complete list of functions. So if we go back here, right, you'll notice at the top there's a main script variable that has been declared right here and initialized right here. Okay? So, to access any of the stuff, you simply start by typing main script dot, and then you can call any of the stuff that is listed here. Okay? Question.
Thank you.
Okay, so we can do main script dot get character location. Okay. And this will return. And when you have this set up properly, it'll give you the IntelliSense pop-up, so you'll know what functions you have available to call. I don't know why something different right here. Probably because I've got another project open at the same time. move down, push, a description available of what it tries to do. So if you try to push and you're too far away, nothing will happen. You can get the character location, the opponent location, the button, the cooldowns of the button, because you'll notice there's a slight cooldown whenever you push a button. Bomb distance, player speed, and bomb speed. Any questions on this? Yes?
Do players and bomb move at the same speed?
Bomb speed varies, so.
Yeah, no, they don't. So, one important thing, and you guys figure this out really quickly when you're doing this. Each time a button is pressed and the bomb starts to go, it goes faster and faster, okay? Now, it doesn't mean that if you push a button, the belt moves faster. It means that each time a button is pressed as it goes back and forth, it goes faster. So what you'll see is almost like a slingshot effect. So you might, if I'm on one side and the opponent's on the other, I push it, the bomb might move at speed 1, and then they push it, and then it goes 1.1, and then I push it, and it goes 1.2, and then they push it. And that'll go back and forth until the bomb explodes, and then the first time the bomb or the button is pushed on a new bomb, it goes back to the initial speed of 1. Okay. Other questions? Yes?
Does anything alter player speed?
No. Nothing will alter player speed. Players will always move at the same speed. Okay? Other questions?
Why is there a get player speed? It's going to be like constant.
So that you can do calculations.
So,
As opposed to just, that's just a way you can access it. So you don't have to go and search through all of the random scripts to figure out how fast they go.
does the like player pause as it like moves past like say button 1 to button 8? Like does it pause at every button even though you don't want it to? Like,
No, it won't pause. It won't stop unless you tell it to.
Okay.
So if you tell it to move up, it'll keep moving up.
It won't go like straight, or it won't like go then stop, then go then stop.
No, it won't stop at a bomb unless you tell it to push it, or a button unless you tell it to push it. Some people, like, we've had some strategies, you know, the blue starts down at the bottom, the red starts at the top. Some strategies have the blue guy go straight to the top before they start doing anything. Yeah, they won't stop at the bombs all the way. So the way this is set up code-wise is you might be on the red side, you might be on the blue side. You don't have to code it from a particular side, okay? So if you just do move up, move down, push, everything is going to be automatically set up to handle you being on both sides, okay? So you don't have to handle, okay, I'm going to do this if on the blue side, I'm going to do this if on the red side. You don't have to do that. It's automatically going to handle that for you, okay? Sometimes you might be on blue, sometimes you might be on red. The only other thing you are not allowed to do in terms of this class is copycat what the other person is doing. Okay? And the reason for that is it's not AI. It's a great strategy and it works really well, but it's not AI. And it's not what I want you guys to be focusing on. Sure, you could do that. Sure, you would win some matches doing that. But it's not a good application of what you've learned in this class. Okay, so I don't want you doing that. You may not simply copy what the other person is doing. And by that I mean, if they're above you, you move up. If they're below you, you move down. If they push the button, you push the button. Don't do that. It's not AI. All right, so any other questions on this? Okay. Close out of this.
So we're allowed to begin the other classes?
You are.
Okay.
You shouldn't need to. I want you just to submit a single file. So if you want to make another class, make it inside of the same file. you probably won't need to make a new class. You might want to write a couple new methods, but unless you're doing something really crazy, I don't think you'll need new classes. And if you do, then just make them in the same class. Yes?
If I remember correctly, the speed is actually related to the frames. So adding too much extra stuff will mess up your
Yes.
in an
So,
unfair way.
good. I'm glad you brought that up. A couple other things that you are not allowed to do. Anything that would give you.
I wasn't trying to like give myself an unfair advantage.
No, and I didn't think you were. But there have been some things that people have done accidentally that they didn't realize really screwed up stuff. Not with any sort of bad intent or something like that, but I want to let you guys know of some things, especially for those of you that aren't familiar with Unity and how it works. So update, which is the function that gets called every game frame, which is where you're writing your code, that gets called as often as possible. Okay, so the faster your machine is, the faster update is going to get called. Okay, the slower your machine is, the slower update is going to get called. And so what happens is, inside of movement, what actually moves the player, we multiply the speed by time.delta time, which is the amount of time in between the frames. And what that does is it normalizes the speed, so that if there's more time in between frames, we move them more. If there's less time between frames, we move them less. So you get a smooth movement as opposed to moving really fast and then slowing down as the frame rate fluctuates. Okay? So the point of me saying that is, if you are doing a lot of heavy calculations, it may slow things down. Now, you would be having, let me say this, you would almost have to have some logical errors and be doing like massive amount of loops for that to occur. But there is one thing that will really slow down running the game, and that is if you're doing a lot of print statements to the console. Okay? So just so you guys know, a lot of times when you're debugging stuff, it's helpful to print stuff out so you can see what values are and that sort of thing. Inside of Unity, inside of Unity, sorry. Inside of Unity, you can do print with whatever inside of here, and that'll output to the console. If you do a lot of these, you can also do debug.log, it's the same thing.
Actually, I think the difference between the two is that if in debug.log, when it prints the console, if you double click it, it takes you to a line of code. I think print just prints.
It'll do that too.
Oh, really?
Print, without getting technical, print inherits from mono-develop. So if your class doesn't derive from mono behavior, if your class doesn't inherit from mono behavior, you can't call print. So just call debug.log. It's the same thing. I think debug.log writes to the log file where print doesn't. But you can still double click on it to take you to the line of code. Anyways, those output statements will really slow down your game. Okay, especially if you're doing them inside of a loop, inside of an update call. Okay, so, and it's totally fine to use them. Just make sure you remove them before you submit. Okay. If you start to lose, then you could just flood the console window with print statements.
It's not a valid strategy.
All right, any other questions on this?
Is your script going to run different depending on what hardware you're running on? Do you have advantage on faster hardware?
No. And I'm going to run them all from the computer here. And so we'll set up a little bracket and play each other. We'll see who wins. Right. But no, we'll be running it on the same machine, so it'll be the same. It won't matter. Yes, sir.
What's the winner do?
Half a point rounded down. I don't know. We'll come up with something good. Winner will get something. Other questions? Okay, so last thing. To submit this, the only thing you need to submit is your script that you write. The one that AI script underscore your name. That's the only thing you need to submit. Upload it to Canvas. Do not submit the entire project, just your script. Okay? Everybody good with that? Question? Alright. What I want to do briefly is cover some approaches to how we can do this. Now, some of you might already be thinking about how you're going to approach your AI, kind of what algorithm you may use. But I just want to cover this briefly in the event that there's something that you haven't considered, maybe something you might be overlooking or underemphasizing. The line got really crooked. We should draw these in red and blue. That'll make it official. You have a blue marker. Okay, so here's a rough sketch of the game board. And we've got some bombs in the middle. I'm not going to draw the bombs. Of the bomb. They look cooler in the game. So here are some different approaches that you can take. When the bomb, let's say we have a situation like this. Okay, this bomb's coming this way. This bomb's standing still. We've got a bomb here that's going this way. We've got a bomb here that's going this way. We've got a bomb here that's going this way. This guy's here. This guy's here. Now, if you're blue, where are you going?
Down.
One. Let me just throw 1, 2, 3, 4, 5. All right, where are you going if you're blue?
2.
I would press 4 and then go to 2.
No, go to op 4. Go to 5.
I would just click, go to 5, press, then press 4, then go up to 11, press 4.
Okay, so the first 3 answers that were given were all different. Okay?
What's the score?
2 and 1.
Right
So
now.
the score might matter. All right, if you have 2 lives, that changes what you do, right? If you have 2 lives, you have to go up here. If you have 1 life, then you really have some decisions to make. Okay? If you have 1 life, can you get to 5 and then get to 2? If not, can you get to 2 and then 5 and back to 1 before it hits?
Depends on the speed and distance.
So these are some things you need to take into consideration. Right? So how many lives you have? Matters. So how many lives you have matters. Now, what if you have 4 lives? Where are you going now? Same place?
How many lives does the opponent have?
Why does that matter?
So you know if you can take them out and then not have to worry about.
Yeah, because he only has 1 life, I'm going straight for 1.
I mean, if they have 1 life, they already have 3 approaching those. So if you hit 4 right now, and then like, I mean, if you hit 4 right now, I don't know. I think they would probably be eliminated fairly soon. You want to be able to get all 4 of them out of the way.
Right?
Or you could just go for all the bottom ones. Like, you clear out your 2, you clear out the 2 that's on the way, you go for all the bottom ones, and then
Bottom ones are already approaching.
Does pushing a button take time?
Yeah, but then it's like, it's cementing the fact that he can't do anything else, you know, so then, because he can't throw more bombs if he has to, like, always continuously throw yours. There's only something.
Right.
But assuming speed and other things as well, there's a lot to take into consideration.
So,
Start copying him.
what's that?
Start copying him.
Start copying him.
Yeah, can we like start copying him like in the middle of the match?
No.
Pause for a couple seconds at a time.
Yeah, I know that. I will look at your code. So, here's a common approach. At any point in time, can you hit more than 1 bomb or 1 button at a time? Okay. Can you be moving towards more than 1 button at a time?
Along the way. Yeah. If you're going to like 1, you'd be going to 2 along the way.
Okay. So there's a simple approach. Simple approach is to use a heap that orders the buttons. Okay? If you don't want to use a heap and you just want to use a list, an ordered list. And the idea here is each of these holds all 8 buttons. And what you are doing is you are always moving towards the best button. Okay, now how you decide what the best button is complicated. Okay? Just in the example that we drew up here, we talked about if you have more than 2 lives and you have more lives than they do, then you can play more aggressive. So we might hit bomb 5. If they only have 1 life, we might go up and hit bomb 1. If we're kind of tied, we both have a good bit of lives, maybe we'll hit 4 and then 5, and then we'll go down to here 6, 7, 8, because we know that they're going to go 6, 7, 8. So there's a lot of different stuff to consider. But at any point in time, you are always focused on moving to 1 different belt. Okay? So as your program runs, it constantly reorders your heap and reorders your list, and you're always moving to the best one. Okay? Makes sense? Kind of like an A-star, how you always move. Each time you pop off the node, you're always moving to the best available. Similar. Okay? There's a cluster approach. And what the cluster approach does is it groups buttons together. Okay? So for example, if we're over here on the red side, these buttons would fall together in a cluster. And what we're looking at here is we may have a situation where one bomb is really close to exploding and we could probably get there in time. Or maybe we've got two here and we're in the middle and we need to try to figure out, well, do I go here and here or does it make more sense to hit these three? Because if you focus on the simple approach, your simple approach is going to tell you to get the bomb that is closest to your side. So you're going to go up and you're going to hit 2, and you're going to hit 3, but 6, 7, and 8 are going to explode on your side. So by clustering these and looking at them in more than just a single bomb and a single belt at a time, you create almost like a heat map of danger. And instead of moving to the single source that is the most imminent danger, you move to the area that is most dangerous. Or you move to the area that has the most potential for you causing the other bombs to explode on their side. Okay? Does that make sense? Now, you might even switch your approach mid-match. Okay? You only have one life left. Who cares about clustering? You've got to get the one that's coming close to you. Question?
Yeah, so I'm going to ask this. How much time does it take to hit a button? When you hit it, still keep moving?
No. You pause slightly.
Okay, so there's a...
I think it's, it might be a second. It's between a half a second and a second. We could look at the actual code. But yeah, there is a noticeable slowdown when you hit a button. Yes?
Is there a method to get that like time that it takes, or is it like a constant that you can find in the code itself?
If you look at the push method, what's that?
It's one of the get methods.
I'm sure it's a hard.
Yeah, it's something like that, and I don't know whether it's done in a code routine or not. There's a cooldown for a button, but I don't know if that's the same cooldown as the player. I don't think it is. So I hit a button, that belt can't be hit again for a small amount of time. Okay. It's in the code somewhere. If you look at the push method, wherever in the character script, that should tell you how long it is. But it's like I said, looks to be about a half a second to a second, somewhere around there. So again, the way we would cluster these is looking at, we could basically come up with a numeric value, a heuristic, on how good a particular belt is. And for example, this one might be, if we do it on a scale from 1 to 10, this one might be a 7, this one might be a 6, this one might be a 5. This one might also be probably be a low number unless the opponent was right here. Then we might want to go up and hit it, okay, because we think that they're going to hit it back. And so what you do is you add it up, you look at maybe series of 3s or series of 2. So you look at 6, 7, 8, you look at 5, 6, 7, you look at 4, 5, 6, you look at 3, 4, 5, and so on. And you add up those values to try to figure out which area presents the most potential for gain if you move there. Okay, whether it's scoring or being scored on. Other questions? Any questions on, bless you, getting Unity, IDEs, scripts, that sort of thing? Everybody good? Yes.
So how do you tell how close the bomb is to your side?
I believe that's in get bomb locations. Okay. It'll tell you where it is. Because you'll get your player location, you can compare that to the bomb location. Also, if you saw, I paused the game. You just hit the pause button next to the play. And you can go to the scene view and then actually click on the bombs and the buttons and that sort of thing to tell where their positions are. So you can kind of get a better sense of what those values mean. Okay, like at what point they hit. Any other questions? Yes,
Can we run our code practices against game AI?
against the ones that are there?
Yeah.
Yeah, so when you download your script, when you download that project, it'll come with those 5 that are in there. You'll modify one of them, and then you can just test it against that. And if you've got friends in the class, and you're like, hey, send me your script, I'm going to play against it. All you have to do is take their script, drag it in, drop it into that folder, and it'll automatically pop up when you run the game. You can play against that. If you want to make a couple different variations of your own and play against it, go for it. I will caution you, in my experience, this tends to be a very rock, paper, scissors type thing. So your approach will beat some and lose to others, but the ones that lost to you might beat the ones that you lost to. And so it just depends. Some counters, if that makes sense. Other questions? Okay.